faster than spacetime's very fabric by itself. It has the capacity to keep an eye on it, and as a result, will gradually destroy this idea of filling me, becoming increasingly uneasy. At this very instant, the night sky is rapidly undergoing transformation, and in the upcoming decades, perhaps even earlier, it could completely vanish from view. Notable experts like Neil deGrasse Tyson have raised the stakes, acknowledging the inevitable changes caused by the change in position of Polaris. The shifts that led to this phenomenon are unexpectedly surprising. Polaris, commonly referred to as the North Star, has been a reliable aspect of the sky for millennia, serving as an essential reference point for astronomers. Despite this, navigators and astronomers alike may soon see this altered, modifying our perception of the heavens and the manner in which we explore the universe. Let's delve into the implications of this transition. For centuries, Polaris has served as a beacon for sailors to follow, astronomers remaining unwavering in the sky. This constant presence has been important for navigating, but this stability may soon be shaken. According to a paper released by the affluent Royal Society of Astronomy in September 2023, concerns were raised about the future of this celestial Polaris marker. It is entering a tumultuous first phase, in which it may explode and disappear from view, forever radically changing the sky we know. Before considering the potential results of this event, let's take a closer look at the features of Polaris. The star itself stands out because, due to its location near the North Star pole, it is situated directly above the northernmost point. It appears almost still in the sky, despite being part of the constellation Ursa Minor, which is frequently referred to as the Little Dipper. Polaris emits light at a moderate level and is categorized as a yellow-white supergiant star. It is a lot bigger and, despite this, brighter than our Sun. Polaris is more than just one star. It is part of a complex triple star system consisting of Polaris B and A as a pair of binary stars orbiting a third star. The interactions caused by gravity between these stars have an effect on their behaviors, orbits, and any disruptions in these interactions might alter their pulsation or brightness. Despite this, the precise nature of these forces patterns is not yet fully known. Where Polaris is located, approximately 323 light-years from Earth, the light we see today began its journey a long time ago. If Polaris were to explode, the effects would remain hidden from view for more than 300 years. Polaris could even have already exploded, but we have yet to keep an eye on the outcomes. Throughout history, the North Star has held profound cultural symbols and navigational importance because of its unchanging position in the sky. It is now an invaluable guide for ancient sailors navigating across vast seas and landmasses. Polaris has symbolized stability and direction, remaining unchanged in the ever-shifting sky. For astronomers, Polaris has served as a crucial point of reference in the study of the motions and variables of stars. As a variable star with oscillating brightness, it shifts on a regular basis, providing important insights into the characteristics of stars and how they act. Variable stars have also exhibited this quality, vital for determining distances across the cosmos and calibrating scientific instruments. Its pulsation pattern has been relatively easy to predict. But recently, Polaris is beginning to exhibit signs of deviating from its usual behavior. This irregular pulsation cycle has caught the attention of astronomers, triggering additional research into the cause of these unexpected changes. Rather than adhering to its typical rhythm, Polaris is beginning to behave erratically, dimming, leading some to worry that the star may be getting close to the end of its lifespan. This behavior follows established patterns in stars that are getting close to their final stages. The steady rise in the pulsation period of Polaris, which was once steady, can be traced back to interactions that take place within its star system. An annual increase in duration of approximately 4.5 seconds in the duration of the pulsation. Though this may appear insignificant, holds significant effects. Some astronomers contend that the forces of gravity between the stars within the Polaris system are driving these changes, directly affecting its atmospheric conditions and pulsation patterns. Others are more concerned that Polaris is entering a critical phase that might result in an explosion. The similarities in behavior between Polaris and that of Betelgeuse, a well-known star in the Orion constellation, are striking. Both stars have demonstrated sophisticated variations in brightness, which has led to concerns that they might be nearing a catastrophic explosion. Stars nearing end-of-life symptoms frequently show such irregularities before their demise. NASA has expressed more anxiety regarding Betelgeuse, but formal attention has yet to be completely focused on Polaris. As a Cepheid variable star getting close to the end of its life, it goes through several stages, including the phase of the red giant, and ultimately ends in a supernova explosion. Given the irregular pulsations observed in Polaris, scientists predict that it has entered the helium exhaustion phase, which is typical for giant stars nearing death. These deviations are consistent with patterns seen in other stars as they near their end stages. But substantial evidence of an impending supernova is still unknown. Astronomers continue to keep an eye on these anomalies to learn more about the fate of Polaris. In the event of an explosion caused by a supernova, it would be a remarkable event in the sky, possibly shining brighter than the moon and appearing for days, weeks, or even months. Its brilliance could make a big difference, changing how we see important constellations like Ursa Major or the Big Dipper, in which Polaris plays a critical role. Thankfully, Earth would probably remain safe whether Polaris explodes or not. Due to its immense distance from us, while Polaris's explosion may not be as stunning visually as Betelgeuse's, it could still be visible to the naked eye for a significant amount of time, outperforming nearby stars. This would undoubtedly draw the attention of observatories and astronomers, producing a lot of interest in the academic community and among stargazers. However, the effect on Earth's environment or ecosystems would be less significant compared to a supernova closer to our planet, close to the end of their lifespans. Through comparison of Polaris to other astronomers, hope that supernova precursors to gain a deeper understanding of the mechanisms that underlie star explosions. Every star's creation and pulsations nearing the end of their life may indicate instability inside or an upcoming catastrophe that provides valuable clues about the processes that, despite the fact thorough evaluations and ongoing researchers continue to be perplexed by the inconsistent behavior of Polaris. Comprehending the reasons for these anomalies is essential to our advancement. Comprehension of stellar evolution. Investigating the underlying factors for Polaris. Erratic pulsation requires cooperation among numerous scientific disciplines, as well as the growth of cutting-edge models and empirical methods. For the possible loss of Polaris as a point of reference in the sky rises. Fundamental astronomical questions. Research ground-based telescopes and measurements of distances between stars would require calibration, which influence the precision of cosmic determines the extent to which the navigation would also be affected by Polaris. Cultural practices and systems that depend on this emphasize the significance of such an event on celestial markers. Polaris's enigmatic behavior emphasizes the urgent need for more astronomers. Conduct-focused studies and research must deal with the difficulties surrounding its irregular pulsations and provide relevant responses to determine the star's future. The disappearance of Polaris would have major implications for various academic disciplines and one of the most important cultural practices. Consequences include the requirement to recalibrate astronomical tools and techniques because Polaris has been an accurate point of measurement. Distances across the cosmos are shrinking, which would alter existing models of the astronomers of the universe, have relied on the star's predictable behavior for centuries to assist them in tracing the cosmos. Without it, there are no other means of measurement, which may necessitate years of research. In addition, Polaris has always played an important part in navigation, particularly for travelers and sailors. Its being in the sky constantly has helped guide adventurers across vast oceans and uncharted territories. If Polaris were to vanish, the disappearance would create problems that modern navigation systems face that continue to depend on celestial bodies' orientation. May be particularly problematic in remote areas where it's possible that electronic navigational aids are as accessible or effective. In addition to practical concerns, the cultural Polaris significance cannot be overlooked. For many ancient civilizations, the North Star referred to a sense of constancy and direction of order in an otherwise chaotic world. Its disappearance would likely possess profound psychological and emotional repercussions for various communities, especially those who have correlated the star with direction and hope. Even today, many cultures continue to interpret Polaris as a sign of inertia, steadiness in the face of life's uncertainties. The potential fading of Polaris emphasizes the fluid and ever-changing nature of the universe. Stars like Polaris experience a variety of stages over the course of their lives, and their eventual death is just a part of the cosmic natural cycle. While the thought of losing such an important and dependable star may appear disconcerting, it additionally serves as a reminder of how intricate procedures that take place in the universe beyond our ability to comprehend. As new stars emerge and old ones fade away, the skies above us are always shifting and evolving. As we continue to learn about the stars and how they act, the changes in the patterns of pulsation on Polaris are likely to supply astronomers with even more details about the person's life cycle of stars and the forces that control their existence. With this information, could eventually assist scientists in understanding the broader processes behind the development, death, and formation of stars. By studying how stars like Polaris act as they get closer to the end of their lives, we can learn more about the mystery of stellar evolution and the ways in which the entire universe is undergoing constant change. Despite the concerns regarding the fate of Polaris, one thing is certain: it has been an invaluable resource for astronomers, cultural traditions, and navigators for centuries. Whether it ultimately goes supernova or transforms into a white dwarf or through some other unexpected phase, its eventual disappearance is certain to mark the end of an era in our comprehension of the universe. However, as with other celestial events we've seen, new discoveries in stars will continue to emerge, offering humanity new understandings of the nature of the universe. As the changes take place, Polaris changes may be concerning, but they also provide a one-of-a-kind opportunity for researchers to investigate the fundamental principles of stellar life cycles and the forces of the universe that shape them. Polaris' future is yet to be determined, but the journey to comprehend its eventual destiny is an exciting one, offering potential advancements in our knowledge of the universe and the forces that govern it. As we keep an eye on Polaris, astronomers are studying its shifting behavior, trying to figure out how this star's transformation might affect our broader understanding of the universe. The possibility of losing a steady celestial landmark challenges us to consider how fragile our current stellar models, cosmic measurements, and dynamics are. Since Polaris has served as a key point for telescopic instrument calibration, the eventual alteration or disappearance of the star could necessitate the creation of novel methods and methods for determining spatial distances. In addition, Polaris' gradual departure from its consistent function in the community of scientists to investigate more deeply the mechanisms that underlie the behavior of variable stars' behavior. Understanding the variations seen in stars like Polaris and their previous conditions and stages could revolutionize how we perceive the star's life cycle in general. These studies may broaden beyond our investigation of the Polaris' influence on additional variable stars and their potential to evolve into phenomena like supernova, neutron stars, or another fascinating white dwarf. The ripple effect is one aspect of the situation impacting it might have on our engagement with the universe. For instance, Polaris has served as the focal point for numerous myths and cultural stories across generations. If the star vanished from view or significantly altered, would alter the way various communities use the night sky to interact with those who used to see it as a sign of hope and constancy. which can have an affective and spiritual void. This eventual change in the North Star's position might also encourage additional research into the intricate connection between gravity and the structure and motion of the stars. Universe. As we venture beyond our actual comprehension of Polaris' disappearance, it might prompt more specific study of the intricate dance between celestial bodies.